So today we are going to solve left view of the binary tree problem. So if you have not seen these previous videos, please, it is highly recommend to watch these videos so that you will get a approach. And there is a level order traversal that I have explained. Please watch this video so that it will be easily understandable for the further problems. So I will also add particular those links in the description so that you can go quickly to that. And let's start this left view of the binary tree problem. So what we have given is we have given the root of binary tree and we have to return the left view of this binary tree. Okay, so consider this is a binary tree here. The left view is 1, 2, 4. Okay, so let's go to whiteboard to understand this briefly. What it is saying is 1, 2, consider 3 we have given, consider 4 we have given here, and consider 5 we here. Consider a person is standing here. Okay, this is the person standing from here, and this is the consider some type of mirror is there. What it will see from here? It will see one. Okay, so one we will print in this level, but it will see. It will see two, right? It will not see. It will not be able to see three because two is covered up for three. So two we will write for this level. What it will see? It will only see four. And for this level, what it will see? It will see five. So we have to return 1, 2, 4, 5 because this is the left view. There is the extended problem also, right view. For that, try to consider person is standing here, what it will see from here. So it will see 1, 3, 4, 5. Okay, because two will be will be shadow behind this three. Okay, so two will not be visible from person here. So it will see 1, 3, 4, 5. Similarly, we have the top view, we have the bottom view. So these are the further problems of this. But in this problem, we will only see like how we will go with the left view. And the problem statement, like the approach that we are going to consider, it will be extendable to the other problems also. So let's see. If you have not seen the level order traversal, I would highly recommend to watch the level order traversal so that you get a better idea. Okay. So let's see. Let's write this particular example one more time to understand like how we will solve this. So consider we have this 1, 2, and 3. Consider this is 4. Consider this is 5. Okay. What will be the level order traversal of this binary tree? If I will ask this level order traversal, this is 1, 2, and 3, and 4, and 5. Okay. This will be level order. This is level 1. This is level 0. This is level 2. This is level 3. Okay. But we need only the first node of the particular level that I can say because left view is nothing but first node of every level. For this level, this is the first node. For this level, this is the first node. For this level, this is the first node. And for this level, this is the first node. Only we need to write this. So what we can do is in this example, we can just take one. This is the first node for level 2. Then we will take 2. In this is 4 and this is 5. Okay, so there can be multiple approaches you can solve this. Either you will take something of reference like consider if I will start the level order traversal, I will write 1 and consider if my level is like ended there, I will store some -1 or some integer value that is out of bound, that cannot be considered in the because all the node that data is positive integers, so we can take some negative integers to finding it out their level is completed. And for 2 and 3 we can consider -1, and for the fourth level 4 -1, and 5 this level is completed, so 5 -1. And we will just see if the next if the previous value is -1, root node will always be the coming into answer because root node is the single node. And for the further nodes, I will check if my previous value is -1. It means this is the first node for the next level. So it means 2 will be the 4 because -1 is the previous value, and 5 because -1 is the previous value. So like this can be a possible approach. The other approaches that can be some approaches you will see like one we can store something right null, and we will check. Similarly, in place of minus we will store the in the queue as a null values, and we will check. Okay, so there can be multiple approaches, but the approach you have to understood is what is the left view. Left view is just nothing but you have to write the first value of every level. Okay, that is the problem statement is concluded. So like this, and we will see like now I'm going to explain like how to use with the null value so that it will be extendable to other problems also. Okay, so I will write the code in Java. If you are comfortable with Java, you can take the reference of this. If you are not, you can take the approach as an example and you can write in your preferred language. But the approach you need to you must understood what I'm trying to say here is, so consider array list that and if the root is null, this is the base case that we have to handle. If the root is null, then we will just return the empty list because we don't have any nodes. And for the queue, consider I'm going to store as queue that is linked list that we need to traverse for the level order traversal. If you don't know why we use queue or how to do the level order traversal, I would recommend you to watch that video. So in that, what I will store is I will store root node. Okay, I will store root node. I will store some null node. So to trace like where the level is ended. Okay, where the level is ended. And what I will check is I will check for q dot size is greater than one. Okay, why I'm checking the q dot size is greater than one? So to make sure like we are not going with the null node. What I mean to say here is consider for this example how it will look like. Consider this is my queue. Okay, and I'm starting with one and I will store the null. This is my initial values. Okay, and initially my array list will only store nothing. It's or you can store the root node also, or you can store nothing. So to let's see. So consider you are starting from here. This is one, this is no null node. So we will check where are the left and right values are present. So left and right values are present. These are two and three. So what we will see, consider two and three, and we will like we will store those values. Okay, and now one is there. Okay, so it means and consider there is a one variable that is previous node. Why we because previous node we require because we have seen right as minus one we need to identify what is the previous value that we have encountered. So consider previous node is null. So if previous node is null, it means there is a this is the first node that we have encountered for this level. So it means this will covered up in our solution. So we need to add in into our array list, and in it means the previous node will then change to the this node. This is one. Okay, now we will check null. If null is there, it means this particular level is ended. This particular level is ended. So it means we have to add again null, so that it means the second level that we have traversed is completed, and now the null node is there for this. So we will add null again. Now we will so this will become null because previous node will be upgraded. Now we will encounter as two. So if we will check two and the previous node is null, it means we this will be our first node for this level, and we will check for the left and right for two. There is no left and right, we will not do anything. We will check, and this will be previous node will be upgraded for two. Check for three. For three, the previous node is two. It means this will not be encountered into our answer because the previous node is something that we have already encountered. We will not going to be take it for further. And there is left or right. There is no left, but there is a right. That is four. Okay, that we will store. And previous node will be upgraded to three. Then we have encountered null. We will just store null again because it means the particular level is ended. And we will say this is become null. Okay. Now coming to four, four previous node is null. It means this will be the first node of this particular level. And we will say four left is particular values there. Then we will store five. And right is not there. Then we will not store anything. And for four, the previous node will be upgraded to the four. Now the null again came. We will store null. Okay. And this will be become null, the previous node. And for five, we will check previous node is null. It means this will be our first node for this particular level. We will store this into our array list. And for five, there is no null, there is no left and right. So we will just store nothing. Now we have an this last element is present, null node. So we will just take out null and we will just say, or either you can only traverse this array list till here, or you will traverse the complete. There is nothing much impact it will. Okay. So it means we also need some previous node that we have encountered that is null. You do, I will highly recommend guys you don't need to do any cramming of algorithm. You just have to understood how we are going to approach this problem. Like if you will write this by yourself, you will understood better. It take the video as a just a reference, like how will you approach the problem. Okay. So for this, we will take the current node out from the queue by using FIFO algorithms, first in, first out, and we will check if my current node is equals to null. It means I don't have to do anything. I will just add null node to my queue. Okay, I will, and my previous node will become the my current node that we will become. And if my current node is not equal to null, that we have pulled out, that is not equal to null. It means this is some value is present. Okay, and then we will check if my previous node is null. If my previous node is null, it means this is the first element of this array list. This is the first element. So what we will do, we will just add the current node dot data, whatever that is contained, we will just add that, and we will check for the queue further size if the current node dot left is not equal to null, then we will just add into our queue current node dot left. And if check for the right version, if that is not equal to null, we will just add the right node also. And we will mark this as the previous node, whatever that we have encountered. So we are doing in this both the cases. So for better maintainability of the code, I will write this statement as here to remove the duplication. Okay. Okay. So we are just checking queue is there. Okay. We are going to add this into current node and we will finally return this resultant array list. Let's see. Yeah, 1 to 4. And if we are try to submit it, yeah. So hope you understood the approach. We are doing nothing, just upgrading the version of the level order traversal. We are just adding more into this. So to track that, why we are adding the previous node, why we are adding this, you will understood better when you are seeing this. Like because for every level, we need to take the first node. Okay. Hope you like this video. Please, if you like, please subscribe my channel. It would be highly motivating for us to keep the continue. And thank you for watching.